Alright, this is the second fundamental theorem of calculus. And that states that the antiderivative of x of something from a to a certain point x is the f of t dt. So the antiderivative equals this with the bounds of x at the top. So if you say this, the second fundamental theorem states that the derivative of this antiderivative is f of x. However, this has to be continuous on the interval, and it has to be open intervals.
Moving on to the examples of the second fundamental theorem of calculus. To explain how you carry out this theorem, I simply have a couple of examples just to briefly describe how it works. And here I have capital F of x is equal to the antiderivative of t, and that means you have an upper and lower bound describing the antiderivative. In this problem, x is always your upper bound. You have to have x for this theorem to work. And your lower bound has to be all reals, in which this has to work too. So what we want to do is we want to find the derivative, d over d of x. And to do this, all you do is substitute the x's in your upper bound for all the t's in your antiderivative. So what you'll end up with is capital F prime of x is equal to f of x. Now, further to describe this, you're in a problem or anything like that, you might have an initial condition which might describe another something which would be f of 3 equals 25. And what this comes in handy for is when you're given an initial condition, the way you would solve this function is to be able to use the second fundamental theorem of calculus to pretty much simplify what you have to where you can make capital F prime of x equal 25. Now, another example of this, just to kind of further broaden what we have, would be the derivative of x is equal to x over 1, x being your upper bound, 1 being your lower, and that's equal to the cube root of t dt. And like I said, all you have to do is substitute your x's for both of your t's. So what you'll end up with is the derivative of your antiderivative is equal to the cube root of x.
Another example would be of, this one's a little more difficult just because it's the derivative with the upper bounds and lower bounds switched than what you would normally think. So since the x is not on top, which is a rule that you have to follow, you have to switch the bounds, which means you bring out a negative out the front. So you have, essentially, since you switch it, you put the x on top, but you put a negative out here. So when you substitute the x in for t, you'll do x to the 5th, but you bring down the negative.